All right, what is this?
Hello, AV. Hello, welcome to Show and Tell. It's me, Lady Ada, with me, Mr. Lady Ada. This is our time to shine where we get to see what people are doing in the community. What are folks hacking and making and coding and soldering and iOSing and more. We'd love to see it. Come on by. We're in Discord, and then you can get the StreamYard link. All you need is a video camera. We're here for the next 25 minutes or so.
And it's a chance to check out what some of our Adafruit team members are doing. This is a sneak peek behind the scenes what's going on at Adafruit. Speaking of, Trevor, you're working on an app that makes IoT a snap.
Yes, I am working on an app, iOS app. It's called IKEA, and it's out now. So let me show you a little quick demo of the app. Let's see. All right. There we go. IKEA. There we go. Right, and all right, can you see that? Yes?
Yep.
Awesome. Okay, great. So this is IKEA. It's a very simple app. Basically, what it does, and it does really well. It basically, like, you're able to control and check your Adafruit devices, and send data, send your data to your Adafruit feed from this app. So here we go. I'm going to log in, and already I have some data here. I have my trusty mag tag here set up right now.
Ooh,
the colors
what are you
fuchsia.
gonna do? Yeah.
I'm gonna change the LED, the neopixels on here. So
Okay.
here we go. I have So I have
Send the value.
Color code already set.
Okay. Set it red. Okay, no, set it to green.
Set it to orange.
That's yellowish. Yeah. Sorry, that's what I meant.
And it's all good. It's orange reddish. Yeah.
Okay,
so that
good.
works and all. Yeah, so that's basically it. And
That's
in
cool.
a future update, thank you. Like, in a future update, we'll be adding the ability to integrate with Apple shortcuts, so it makes automation super easy. Do you guys want to see a quick demo of that?
Yeah.
Also?
Yeah, why not?
Super quick.
No,
All right,
it's
cool.
not available yet.
Right,
it's still in development, but this is
It's not.
Show and
Yes, that's right. That's right. All right, so here we go. So basically. Yeah. So right here, the last value I have, it says, hello, show and tell. And what I'm going to do is I'm going to send myself a text message using the Shortcuts app. And I'll do it with my phone closed. Already I have. I need to schedule it. Super simple.
But can you go back? I just want to see what was the thing, what was the shortcut itself?
Oh, yeah. Let's see. Text me the last value in my Adafruit feed.
Oh, okay, yeah.
So you can easily modify that to any feed that you want. It also works with Siri, which is pretty cool. All right, what time is it? All right, let's set it for 1 more minute.
We can get back to you if you want to do like 7:35, and then we can, if you want to.
Sure, I think I wrote it through.
Your phone says it's 9:41. Kind of weird.
Yeah, it's gonna say that it's like some kind of like privacy thing.
Oh, okay.
Yeah.
Sorry, I just gave away that it's not. I did the privacy.
Ruined. No, it's okay. But basically, like, I can leave my phone at home and or I can do whatever, and it'll just handle it. It'll just make a network call, and then it will send that value to my it'll text me that value, and whatever else I want with it. So yeah.
Okay, cool.
So that's basically it.
Can we see it? Wait, so you did send you the text or it didn't yet?
I think so. I didn't send it yet.
Okay.
Oops.
Yeah.
Well, I didn't set it. Oops. There we go. And right, so this is the setup right here.
Yeah.
Hit done. All right. And so at this time, let's see, change it to 35, 36.
Yeah.
Hit done.
Yeah.
And then at 7:36, I'll get another text message.
Okay, we're gonna check back in a minute.
Okay. Okay, check back in a minute.
In 30 seconds. What? How?
I think it'll work.
It should be in like 30 seconds.
Okay.
And if folks want to play around with the current version, they can just search for Adafruit in the App Store, or IKEA. And one of the goals is for you to be able to make something really easy, like you just want to turn off the garage light, or you just want to get notified when the garage is open. There's a lot of single serving IoT projects that people just can't do. That's too hard, it's too complicated, or it's a device you have to buy and then you have to do a subscription, and then the company goes out of business, and who knows. This is for you to be able to take control of your IoT devices and then be able to use a free service like Adafruit.io. And we'll have things like geofencing and push notifications and more. This is just to get started.
Okay, so you just sent you that text message for the feed. Hello,
Yes.
Chantal. Okay, great. And you can even see it says it from
io.io.
Okay, cool. Intense. All right. Well, there's a lot of there's a lot going on here, but
well, you don't usually see demos like this live. I mean, even large companies do pre-records now, like Apple and Google. They don't really like show like, here's IoT stuff, because it just is difficult. So that's our app. Check it out. Trev, good work.
Yeah. Thank you.
Alrighty. Next up, Scott, what you got going on?
Hey, how's it going? I've been hacking on some Spy Flash stuff, and I just wanted to remind people, I guess, that there is this extension that we've created for Spy Flash analysis in the Salier logic analyzer program. So what this does is it takes Spy or QSpy Flash and translates it into information about like what is actually happening on or during the logic capture here. So this is, for example, reading a particular address over a dual read command here. And I've actually tweaked it a little bit here to work better. So I modified, it turns out their analyzer, there's like low level analyzers and high level analyzers, and their low level ones are actually open source, which is cool. So I took, originally it worked with just their simple parallel capture, but their simple parallel capture has no idea what chip select is doing. And so the high level analyzer that does all the Spy Flash stuff had to do like some heuristic around whether a transaction's done or not. And it's not always right. It's not always right. And so what I was like, oh, like, cool, I can actually modify it. And so it's now chip select aware. Whereas when it's still going to do the parallel capture. So every clock, you can see here, it marks.
The chip select is active high, not active low.
It's active low.
Oh, it is active low. Sorry.
Yeah, and I could make that configurable, but I did not.
Yeah. Well, I was like, I for some reason I thought that it was. I saw the little pulse. I was like, oh, because I'm so used to little data transfers. I was like, oh, it's a little data.
Right. So no, it's active low. And previously we would just use a heuristic to know like, oh, this clock gap is longer than we expect. But it turns out that you can actually like still have transactions with clock pauses, and so it makes it all kind of tough. So instead, what I did is I took their open source simple parallel low level analyzer and realized I could hack that to create one that does the hard part for me, which is the chip select stuff. And so we have the Spy Flash extension that you can install. And then I also pushed the source under my GitHub for this chip select aware version of simple parallel. The high level one will work in both, or work with both, but it'll work better with this new chip select aware version. Because it doesn't have to do any of this like, yeah, I think the transaction's done based on like timing. It can actually just look at the chip select to do it. And I think it'd be cool if we have like dual Flash and PSRAM next to each other. This should be able to actually like, you can have two of these chip select aware simple parallels, and then two of the Spy Flash analyzers. The
Espressif, the ESP32 series, they usually have the Flash, not the S3, but the S2 and the classic 32, ESP32. They have the Flash and the PSRAM on the same QSPI port with separate
Right.
chip select lines.
Right, and we prototyped that with, I think I showed that off on Show and Tell last week, where I had soldered the PSRAM on the IMX 1011
Yeah.
directly on top of the flash. And it's the same idea. Like most of the wires are shared, but the chip select is different. So this will allow us to actually understand each of those independently, which will be really
Okay.
neat.
Nice
and
work.
it's just more reliable.
Tooling is always good. Tooling always helps. It's worth it to put the effort in.
Yeah, and it's for microcontrollers like the IMX, where you're reading your code from the flash as you execute it, you can actually get an idea of where your CPU is wandered off to if you read the addresses that
it's like the Matrix. You're like, wait a minute, yeah. Okay, cool.
Yeah, and then you can check like, oh, it's not going that fast and that sort of thing.
All right, and folks can tune in to this and more this Friday.
Yep, deep dive this Friday. I might actually do some 1060 PCB design because that's kind of fun too. We'll see.
Take a break.
And then next week, Tim Fomiga will do it because it's around a US holiday.
Okay.
And I'm taking it off.
All righty, thanks so much, Scott.
Yay.
Yep, thanks to Tim as well for filling in.
And thanks, Tim. All right, next up, Jepler, what you got going on here?
Hey.
Hello, I've got a neon shirt here, but I just wanted to show off. I've been learning about the ZigBee protocol, and I created like the very simplest and most inflexible demo in Circuit Python. So my program here really isn't doing much, but it comes down here into its loop, and it says, get me the light power from ZigBee, and then it sets the NeoPixel accordingly. So actually we can hide that now. I'm going to see if I can. This is not going to show, is it? There's an LED here. So this one says SW. This is a switch firmware running just an ESP-IDF program. And if I hit that button, or maybe that button, well, anyway, this demo is going really well.
I can see
Can I be
the light does turn on and
a
off.
freaky person and be like, hey, don't plug those. Is that conductive foam?
Yeah, that's a bad idea, huh?
Yeah, it's a really bad idea.
All right. Well, I'll fix that in just a second.
Okay.
But yeah, so ZigBee message coming from this one, going to that one, and turning on and off the LED, although you can't see it because the brightness is down so
we
low.
believe you.
So there's a branch over on GitHub where I've got this work that actually implements it in Circuit Python, but it's really kind of, like I was saying, not very flexible. And we're going to look at some other wireless standards like Thread and Matter and kind of make a decision about what to do. The dream is to do sensors and things that will show up on your home automation system that you already have, but it's really a learning process for me.
Yeah, like the C6, we just added, BLE support for the ESP series, and we've had Wi-Fi for a while. So, it has the ZigBee chip. I was like, oh, this would be kind of interesting. And I sort of let, like I say, let Jepler kind of wander off into the cornfield and just like, I don't know what he's going to come back with.
I didn't mention that, but these are the C6 dev kits from Espressive.
Yeah, we definitely learned a lot. And it's cool that you got it working, even though.
Yeah, it works at all. So I'm ecstatic after... some really wandering around in a cornfield maze. It felt like.
Okay. All right. Well, this is really good. But yeah, we're gonna keep exploring with Matter and stuff, and just kind of like scoping out what can be done. It's like a lot of. I mean, I kind of say to people like, there was like, hey, why hasn't anyone else done this before? And it's like, no, everyone's waiting for Adafruit.
It's hard, and you have to gather all this information and also understand what people want. And I have no idea what people want, but I can gather information on the internet, so we can work together.
Like, you're doing stuff. Scott's helping. I have ideas. Phil has ideas. Like we're like we all do research together, and I think that's one of the things that's really cool about like Adafruit is we work alone but together at the same time. Like we're very good at that. It's like we trust each other, but it's also like, hey, I got you. Like, do you need a break?
And I do need a break, so I'll be looking at MP3 stuff again and doing a little guide, but that's not started yet, so don't ask.
Okay, like it's just like this is behind the scenes. People are like, what's going on? And it's in again a branch if people are interested.
I will drop that link in the Discord once we finish up here.
Yeah, check it out if other people are interested and want to experiment. But yeah, there's so many compile time things that it's not suited for Circuit Python yet.
Yeah, that was one thing we noticed. Like you have to make a decision when you build the Circuit Python software. Is it going to be, and I'm going to get the nomenclature wrong, there's the router and there's the end device, and you just have to decide that when you compile it. And one is more appropriate for a permanently powered thing, and the other is what you need if it's a battery operated
Yeah.
thing. And you just have to decide, and that's not how that doesn't work great with Circuit Python. I don't know if Matter's different, but we'll find out with ESP's Matter library. We'll read it and we'll find out.
I have no idea either.
No idea.
I trust you. You know, I know you'll come out the right.
All right. Thanks so much.
All right. See you around.
All right. Thanks, Jepler.
All right, and you got some communication equipment that you were going to show off.
This is a continuation of my series on gear that I was making at Caltech. So, oh, excuse me, just a second. Oh God, there's a squealing in my phone. So that is the signal that I plugged the handset into this 300 baud modem, and it starts to handshake and talk over RS-232 to my computer, which is back there, if it was working. Like a lot of people these days, I don't have a hardwired landline, you know, so it isn't going to work. But still, I built this modem, and they said, you know, just built. I got the shell and the transceivers in a surplus store, and then I looked up getting some chipsets to do the actual modem stuff from TI. And they said, well, it's not fancy enough for a class project. So there's this keypad here. I cannibalized an old touch tone phone. And then I realized the keypad elastomer was too fragile, so I had to put individual push buttons underneath the buttons. So it does touch tone. You could actually dial the phone number, and has a switch here for if you're answering the phone or making a call. So this is how they used to do it, and then after this, it started going to units like this. This is
What? Blasphemy.
Yeah. What? This is a Hayes modem. This is actually 2400 baud, which
classic.
is, yeah, this is huge. These were the bread and butter of the internet for the longest time. They were expensive as all get out. So a lot of us used clones and various things, but at least you could plug the phone in the back and not have to go through some sort of acoustic coupling. So
Yeah.
those were popular until
I don't think couplers went above 1200 baud, did they? I thought they were, I mean, if they're 300.
yeah, the couplers you couldn't. I mean, I think even 1200 they started using.
Yeah, 1200 was kind of maxing out.
Yeah. And then they used the external boxes, and then after that, maybe 9600, you started getting into the cards that were inside the computer. So you go into used computer shop, and there's going to be this huge box of what they call Win modems, because they were only worked in Windows, and they were in every computer, and no one uses them anymore, so no one wants them.
Yep.
Okay.
All right. CompuServe memories just like came in.
Yeah, it kicked in hard.
I splurged. I had a 57.6. I was flying.
Well,
I was X-modeming like never before, and then Z-modeming.
Kermit, you remember that? Mm-hmm. Yeah. So I'm still playing with serial stuff, RS-232. You did some nice breakout boards in the shop.
Yeah, maybe you'll try those out. They'll be fun.
Yeah, I've got some experiments going between the IBM and my modern computer, and I'm going to write it up on
You can totally make like an Arduino to modem adapter. You know, you can dial up. I don't even know there's dial-ups available, but you can maybe dial up.
There, and you can actually get to some BBSs through internet protocols. So there's lots of good stuff, and maybe I should document some of that too.
Okay, cool. All right, coming soon.
Mm-hmm.
All righty, next up we'll go to JP, and then Liz. You got about 5 minutes each. Take it away, JP.
Hey, all right. So I've got a little gizmo here that I've been working on. This was a suggestion from Lamore to build a little servo tester. So people who do things in robotics and animatronics often want to just plug servos in and test things like their sort of range that they can go, how many degrees in each direction, as well as adjust things like the pulse length to get the proper behavior out of it. So this is my attempt at doing a fairly bare bones version. It's just a perma-proto board. I've got a ESP32S2 reverse TFT feather, which gives me a display, and you won't be able to read it too well, but you can see here as I turn one of these two rotary encoders, I'm adjusting one servo that's up here, and its angular readout is showing up on my display. And I've got a second little knob there for the other servo. And then I decided to use some of these functions here. I've got buttons built onto the feather so that I could pre-record positions. So these are 3 coordinated positions. So each one of them has 3 positions stored. I can go and change those. So if I, let's say, crank this one right here, hold the encoder down and press the 3rd button, now that's stored as that position. So I've got those.
It's like a Chuck E. Cheese on your desk.
Right. Like a little animatronic would be great. Maybe I'll introduce Lars to this, maybe not. That could go poorly. And I can also, with a press of both of these, have it just run through those animation cycles. So you could record these for other use, or you could elaborate on the UI so you could actually store longer animations if you want. They're just single angle values, and I don't really have timing involved at this point. This is all running off of I've got the feather on a little LiPo just to keep its power away from the servo power so I don't brown out. And this is just, the servo is just running off of 4 AA's right now, or you can plug it into the wall if you're going to be using it a lot. And you can just unplug your servos and go grab other ones to try and see if they're compatible. This one happens to be pretty nicely compatible here. So now I'm controlling a second servo. That's
a useful tool.
A useful tool, yeah. So I'll be diving into this more on the show tomorrow if people want to see details about it, the code, and then I'll be writing up a learn guide pretty quick, straightforward. It uses pretty much all Adafruit parts, including our cool swirly grid there to mount it all.
Thanks, Scott, for the design.
Thanks, Scott. Yes, thanks, Scott, for that design. It's really, really useful for things like this to just quickly build your stuff without even cracking out a drill or a laser cutter.
Did you put those plates on one of the Tuesday shows, the product pick of the week?
I don't think I have. Yeah, I could do those as we could
maybe
do
it next week, because it's like you've got this cool build you could show.
Get them cheap to people; they'll love it. Yeah.
I know that there was one that you had to skip because we sold out a little bit too fast.
Right. Yeah. Okay. That's a good. I'll add that to the list. Thanks. All right.
Okay, cool.
Okay.
Thanks, Creepy.
All right, Liz, play us out.
Hey, how's it going? So I've been working on a PCB design, which you folks talked about on Desk Lady Ada. So this is going to be a drop-in PCB for the IKEA bin directing, which I currently have torn apart on my desk, and it's an air quality monitor. And I did a guide a little while ago where I added a Qt Py to it so that we could be sending the data to Adafruit.io. But this new board we're working on is going to have an ESP32S2, so it'll be IoT right off. So I just sent them out to be fab, but before doing that, we have a guide from Ruiz Brothers that talk about how to take your Eagle PCBs and bring them into Fusion 360 to have a 3D model. And normally people then use that, for more Fusion models. But I wanted to try printing it out so that we could try the clearance, because the big thing about this PCB is, will it fit in the housing? So this was our first placement that we did. And you can see there's a cap here and the fan header here. And I realized that when I put it into the housing there, that the cap was colliding with the sensor. So by seeing that ahead of time, we were able to go back, move things around. So then the fan header is here now, cap is here, and you can see that it's fitting nicely. All the holes are lining up. And then what was a nice surprise was when I close it up, you can see that the USB, if I can get into frame, is going through the USB slot.
Nice.
So hopefully everything will be good size-wise. And then I also printed out the other side with the NeoPixels. We'll have NeoPixels on the front here, so they'll be illuminated. And I wanted to make sure those were lining up, and those lined up nice as well.
I think it's just, one of the cool things is I've been working with Liz on this project. I'm just her spotter. She's actually doing all the work. And what's cool is I've lived through learning EagleCAD and design and having to revise something 6 times. And I'm just hey, here's all the things that are likely going to go wrong. So let's 3D print the model to make sure that all the clearances work out. Because I didn't catch, I I tried with my calibers to measure, but it's like really hard to get like every dimension right.
Yeah.
It's like flipped, and then like you did that and you realize like, oh shoot, we should move a component. That would have been like just one revision on its own, and every revision is like 1 to 2 weeks. So this is like how you can really speed up your prototyping and design by all these little tips and tricks using tools like a 3D printer, not to design an enclosure, but to design the board to fit in the enclosure. Especially since like some of these components are pretty high and you need like cable clearance. So I thought this was very cool because I don't know anyone else who's done this. But I like that we actually learned, when we did it, you learned something and you changed the
People
design.
probably do, but you usually don't see the work in progress.
Right.
And I think people are scared to show their works like, oh, I was perfect. I didn't need to print a 3D model. Yeah, you did.
Because most people like, oh, print out on a laser printer like a 1x1 model, but that doesn't tell you the height. Also, you want to do like for the USB, does it fit through, and like is it going to clear it, and is it long enough, and also is the buttons pressable? Like there's a lot of little details that it's like until you have the physical shape, really hard to know. I mean,
it's nice that it doesn't have to be a great 3D printer either, because you just need kind of like the basic shape.
Yes, exactly. And like we got the little bumps for like the resistors and stuff, and that was another part we realized we needed to move. There's one here with the clip, but and like it's not like the best print because there's so much detail, but just getting the shape and everything I found to be really helpful. So definitely recommend.
Very cool.
All right, great work, and we'll continue to cover this, and this will be a new board soon.
I know. I love that the speed. I love just like we're doing it, revising. We don't even have to no PCBs were ordered. Only took an extra day to get that 3D print, and
no PCBs were harmed in the making of this.
Right.
I mean, less waste, less stuff traveling. It's a good thing.
Yes, definitely.
Okay, cool.
Right,
Thanks, Liz.
Cool. Have a good one.
Alrighty, that's our show for tonight. About half an hour on the dot. Thanks for making this best half an hour of the week. Every single week we do the show until on Wednesday, 7:30 p.m. Eastern Time. Tune in next week, Wednesday. It'll be us or someone else from Adafruit, and you can see all these things and more. This is also on all the places where we put our videos, from YouTube to LinkedIn to Facebook to Twitch, all those places. See everybody next week. Ask Engineer starts in a few minutes.
Bye, everybody.